Welcome to TechTidBits, late night tinkering once more. It's been a while since I've done this. This session I'm going to build a battery. I've got a device ordered for my HTC Vive coming from China, and hopefully it arrives. If I interpreted the purchase form, it was a site called Taobao, correctly, then it should be on its way. Now I'm presuming when it comes, the kind of battery it uses, I can make my own a little bit better. They've gone with the USB biosphere, so it means you can get a really good cheap battery bank. The big problem is the batteries take 20 hours to charge because they use the USB kind of 5-volt limit. And there may be some out in the future that are better, but I think we could build a battery for this. I'm presuming a lot, and from the pictures I understand they're basically 5-volt and a 12-volt feed. So my plan is to use these 18650 batteries in a kind of parallel of 3 times 4 to give us a 12-volt range, and then we'll use some little volt regulator. Now if you're not familiar with 18650s, these are like super common for a lot of people who use the vape. They're really good because compared to the batteries we're all familiar with, like the AA's, AAA's, these can output quite a lot of power, and they also store quite a lot of power. So this can probably store 2 times your iPhone battery for good quality ones. Like this is a Panasonic, and they're quite expensive. They're about $7 each. The reason they call one 18650 is because they are 65 millimeters long and about 18 wide. And I'll say, if you buy a battery bank, or the battery bank that's supposed to come with the TPcast, it will be like this, and the size of this is because they have these in. So generally this is a 20,000 milliamp hour, and they'll have 2 sets of this. So basically here we've got 3.7 volts. We've got all the batteries in parallel, so that means it improves the capacity 3 times. So this is these 3,400. So you get pretty much 10,000 milliamp hour in there, and then you could have another 3. Like so. I have a 4-cell battery, 1, 2, 3, 4, and with these having 10,000 milliamps in each pack, then we'll end up with 40,000 milliamps. And the battery with the TPcast is supposed to be 20,000, so ignoring all inefficiencies and all that, which could be up to 20% of going through the voltage converters and things like that, if they quote 4 to 5 hours and we're doubling it, we could be getting up to 8 hours out of this battery I want to create, and that's ideally what I want, because I do mess around with my Vive for 6 hours, 7 hours at a time. So having an 8-hour battery would be perfect, and something I can just charge into 3 hours rather than 20 hours. So that is the goal of this, and for protection I'll use one of these, so you can actually set it down to the lowest voltage you want to go. So I could put it on 2.8 volts for instance. And when the battery gets down to that, it will start beeping and ringing, so then I know, okay, I have to stop using it, because otherwise I'll may destroy the battery packs if they get too low. And I will charge it via something like this, which is just like a hobby charger, and this will do up to 8 cells I think. So we're only going to have 4, so I'm going to put a charge control lead on the battery, but just plug it in this, and away we go. Now for the TPcast voltages, we're going to have 12 volts. Now I could use one of these, just so this will be 16 volts with 4 cells, and it will drop. We're going down to 2.8 volts, obviously that will drop when each battery drops to 2.8. So you can use something like this, so you can have a 12 voltage output all the time from the battery. And I believe with the TPcast it's also a 5-volt feed for the initial USB controllers and all this. So I've got a smaller one here, which I can also use to regulate it down to 5 volts. Now the reason it's better than one of these 7805s, I think they're called. Yeah, so we could use a 7805 to regulate the voltage, but the problem with these is they generate a lot of heat, and depending on the ampage you're putting through, they can be quite inefficient, whereas this kind of voltage converter are a lot more efficient, and they don't generate as much heat. I've actually gone through and charged all these batteries up on my night core charger. It seems to be pretty good, pretty fast, and it's a nice idea before you put these in to a pack to go through them all and check. The voltages are pretty good, so you don't have to balance charge them, so I don't know if you can see that. But that one's up at like 4.1. And then 4.1's at pretty much what I want, yeah, so 4.12 is pretty good. And then, so I go through them all before I do that, and I'll check 4.12, make sure they're all in there. When with good batteries, when you've got them in parallel like this, they will even out. So if this one's a lot lower, it would transfer into that. If you get a bad battery, it will drain the pack. But in serial like this, so you're stepping the voltage up, they won't. Balance them out, you have to put a cable on each one of these and use a balance charger to do that. So what I'm going to do now is I'm going to put these in freeze. I've got a little DIY welder for these because they're hard to solder. So I've done this before. I've got a little vise here which kind of mounts them quite well together. So I've got this little strip stuff. I think it's nickel. So glasses on, welding tool at the ready, and I made this DIY one because I don't really do this a lot, so it's kind of ideal, cheap and cheerful. That works a treat. And this will allow us to also solder the cables on quite easily. Give me more power, Scotty. That should be good. So those three are welded together for life now. Got 4.12, so that was the highest voltage. And now we'll basically start putting these in series now. And it will step up the voltage for each battery pack, so we'll put them like this. That should get us up to 8.2 volts because they're full, so it's 4.1 on each. And then we'll do another one for free. I don't know if this will touch, but we'll see. Up to 12.3. Yeah, so 16.5 almost. So that will be our total pack. Max power, max capacity, and it will drop down to below 12, and then we'll use a power regulator of some kind to keep the voltage the same for what we're supplying. So we'll be like two like that, and then two on top of each other. I'll have it staggered a little bit like that, and then we'll put some kind of protection on there. Now we have 4 cells, so these all should be 10,000 each. And now we're going to join all these up, so we should end up with a 16 volt battery with 40,000 mAh in serial. So ideally it's negative, positive, negative, positive, negative, positive. Well, not ideally, but exactly. And that's our 16 volt battery, but that's not the form factor we want. If we was having it in a bike, it's not maybe what we want. So we're going to do very similar. We'll start with the negative, and we'll put them like this and just stagger them over. So like this. So if we start here with negative, we go over to the positive, over to negative of the other cell, to the positive, and then we'll put the negative here, like this, of this cell, actually, yep, like that, sorry. So we can go across, and so we can go negative, positive, negative, positive, negative, positive to the upper one, and then positive, sorry, negative, positive to negative, and then positive to this negative. And then so we'll finish over here, and we'll have the negative and the positive together. some like Gorilla Tape around the outside to stabilize it. I was going to hot glue it, but every time I hot glue battery packs and I take them apart again, it's a mess. Now, you know, even though I want to use this a lot, I probably will end up using a different project in the future. And so this should be something like, was it 16.8? $16.5. So now we can start looking at putting the balance leads on here. So we're going to use this guy, but we only need 4 of them, or 5 of them, sorry. So it always starts with black, which is negative. Maybe we'll use that for something else another day. And then so with this, basically you start on your first minus with black, and then you'll go to your middle junction between the 4 and the 8 volt, and then that will be the 8 to the 12, and then the yellow will be the 12 to the 16, and then the blue will be the final one. Okay, what I've done here is I'm going to put the balance leads on, so starting with the black on the negative side and run your way through. So with our little device, I've got a new one here, you have to plug this guy on. Now these are not the main charge leads, these are just the balance leads, so these are for like low voltage, just for bringing up any of these 4 cells individually to make sure all the cells are at the same voltage, so then when it puts the main voltage in there, they'll stay charged evenly and hopefully run down evenly. So we put our little indicator on, and that will read number 1 4.07, number 2 4.15, number 3 4.13, number 4 4.08, all of them 16.4. Now what we can do here is you press this top button, we can give the lowest voltage, so we want it at 2.8, say, that's what I was thinking of putting it at. So now when the cell gets to 2.8 volts, well, when one of the cells, any of the cells gets to 2.8 volts, the alarm will go off, so that's when I know to stop using it. So it's a battery management system, but there's some manual there, which I prefer a little bit than the fully automated ones, because I've had those go wrong a little bit. And then for charging, I can use my high ampage charger, which will also do balance charge as well, and it will charge a lot faster. I just created a little lead for an XT60. These are supposed to be good for 60 amps, so this will be more than enough. And this is what I use for a lot of my stuff. So, and we'll go a bit extra cautionary with some more heat shrink. So now we can put these guys on as the main charge light leads. So I've done a bit of cable management there, so I've got them both coming out. We can just plug this in again, black to black, which is that way. And it'll beep for us. It'll say, yep, still got 16.4. And that's good. So that will be part of the kit. Now what I may do, if this all works with the TPcast, is I'll split these wires off, so I'll have one of these permanently attached. Because it doesn't really use any battery, and it's fine to do that. And then I have another one coming off for the charge point for when I do the charging. So I'll display how that works with the charger in a bit, and now I'm just going to put some padding on. The only problem with this now is getting this over the length of it because it's extremely tight. Hopefully we can do that. Kind of turn motion and Yeah, so that gives you a really nice package. It's sealed, it's safe, it's kind of bash proof. And that is a 40 mAh package. Okay, so this is my kind of hobby charger, and this will do up to 6 cells at 8 amps, so it's pretty good, up to 80 watts. And with this, basically we've got a main charge port, and then we plug in the balancing lead into the side. And on here we can go to, so it's got lithium ion, fast charge, and we can change this to discharge, so we could run a discharge on that, and we can also do a balance charge. So when you click it, it's like, yeah, do you want lithium ion? Yes. What kind of ampage? So we can just leave it at 1 amps. That's basically its nominal charge, but it will take it up to 4.2 in each battery, I believe. So if we do that, it'll just check the battery, and then it comes up and you can confirm to enter, and it'll give you the total voltage, so 16.47. It will give you the actual mAh it's put into it, and if you press it you can look at all the cells. So you can see most of the cells are, as we tested them before, they're all around 4.12. I've got the battery. Now again, assuming the TPcast ever comes, it's 5 volts in, obviously, because it uses a battery bank, 5 volt battery bank. But the Vive, and I'm sure the Wi-Fi has built in the 60 megahertz Wi-Fi, is going to be 12 volts. So I'm wondering if with this battery I can supply it the 12 volt directly, and I can also give it a 5 volt supply. Now what you need to do there is like stabilize the voltage, because as these batteries, they'll start off at 16 but they'll drop down to 12, and I'm wondering if I set it at a certain voltage. So we can see here I've got 16 volts coming in on my bench meter, and we've got 10.2. So if I adjust this up to 12, it's close enough. So now, if the battery was to drop voltage, so if I turn it down, I'm wondering how it stabilizes. So it's down to 15.4, 15, 14, 13. So that's perfect. So that works a treat. So that's stabilizing it. I'm down to 12.8 now, 12.7. So the battery wouldn't, you see now it's just starting to drop off a little bit. We're at like 12.3 there. If the battery's getting that low for those 4 cells, probably going to damage it, so I won't be going that low anyway. So this little converter is good for 12.5 volts up to 16.5. So that's ideal. So this was really working. Now I've got these small ones. Ideally I was going to use this just for the 5 volt, and if I could use it for the 12 volt too, that would be delightful. So I'll switch that over and try it. Okay, so I've got this little guy hooked up now. Now these are super cheap. They're only like, I think they're $2 each, $10 for 5. Can't really beat that. So I've got it set at 16 volts, and it's down on 5 volts coming out, and I'm going to bring the voltage down. So yeah, again, the battery is full, and then we're using it, and as we use it, it drops. So need to see if that will retain. So I'm down 14, 14.5, 12, 12.5. So yeah, that's good. That's pretty good all the way. It's even better than the other one actually. Now I don't know what kind of heat. There's no amps running through at the moment, so it's a good test. But I really need the TPcast to see what kind of current it uses. Also, we'll put that back to 16, and I'll take this up to 12. That's close enough. It's pretty close. So now we're at 16 volts, battery full, and we'll bring the voltage down. See if it stays around. So 14 volts. Oh, so it shut up there, I think. That's not good. So let's do that again, back to 16. So we're down at 15 volts. 15 volts is still good. 14.8. 14 still. Whoa! So we've jumped up to 12.6. As soon as we get down to just below 14 volts, it's jumping up there to up a volt almost. And now when it gets close, it fluctuates a little, but it's not crazy. So that's the idea. Is we're going to use this battery with a TPcast, and I'm going to have two feeds coming out, one 12 volt with one of these guys to steady the 12 volt, and one 5 volt for this guy. It seems it does better with the 5 volt than it does the 12. And we'll have to do, once it's got some amps running for it, see how hot it gets. We need to put a heatsink on there, or you might have to put some capacitors on there to steady the voltage out a little. Okay, so if you ever build a battery, a really good thing to do is discharge it and charge it a few times while you're around. You don't really want to be leaving it on charge while you're away. And if you do, you want to put it in like a plant pot or outside or somewhere where if it does go off, then it won't burn your house down. But I'm going to do another video based on the battery and all this once I get the TPcast. I'll probably do a video on the TPcast, and I'll also do a video about me kind of modding this battery into it. If it's even positive, I don't know. If you stayed around, I've got a little surprise. I'm going to play one of these batteries and figure out why they always try to put them in these stupid plastic cases in case of danger. Like, do these really save them? Are they made of polycarbonate? Are they sealed? Are they fireproof? Let's find out.